So last time we created the RStudio project Starfy and downloaded the data in the format of CSV. And also we talk about the basic concept object. And this week we will start from functions. So first, go to your Starfy folder. Wherever you put it, I think mine is on the desktop.
So we're getting that file out of the email that you sent.
Yes, that's the file you download from the email. And when you unzip that file, and you will see this Starfy.r project file.
Do we need to unzip it?
Yes, we need to unzip it. And you will see the folder of Starfy. And in the folder, we have the file Starfy.r project.
I unzip. It just opened.
Okay, but you should unzip it.
It doesn't have an option to unzip on the mouse.
Oh, you can download to your computer and unzip it.
So then I think you need to use extract all.
Yes.
So we need to make sure we're sharing those steps with people. So now we have the file and we're going to do what?
You unzip the file and you see this Starfy and you click this file to start a new R session. So you will see kind of the three panes, and the left is the console, and to the right there are two panes. The top one is the environment and history, and the bottom is you have the files. And you can click Starfy and go back to kind of the project, the working directory.
Fine. Try to get to.
So you have the two folders. One is data, is another one is script. And this time we're going to create another R script. So you're going to use that button on the top left, this with the plus sign, and you can click to extend. And then the first one is R script. Click R script to create a new file. First, we can save this file to the scripts folder. You can just click this save button and then select scripts and you can name it to data in and click. And then here you can see in your files tab and in the scripts folder, you have a new file saved. So we can have some information about this file.
I just extracted the file, so I just got it. I just got to this page.
Yes, and then you can create a new. You can click
script.
plus sign. Oh, no, this is plus. This is create a new project. So we want to create a new script, the one to the left, with the plus sign. Yes, that will create a new file.
Yeah.
And then you can save it to your script.
Yeah, why don't you redo the steps on how to save it? I think we still have a few people lost in Zoom and a few in here.
Okay, so when you create a new file, it doesn't have a file name here. You click this save button, it will opens, okay, let me delete this one. And we can create, click this plus, the button to the most left, it has a plus button, and then select our script. It will create a new file. It says untitled 1. And you want to save it. It opens this folder, Starfy, and you pick scripts and you name it S2 data in R, and then you save it. Want me to do it again?
I think we're good. It looks like we just had somebody join, but I think everybody else is good. Are you good?
You can save it as
Yeah,
a
that's
new
right.
R file.
And just label it. File name right here.
That's what this.
Mhm. You can name it the way. So the same as last time, we can add some information. Let's say we can add, first we kind of key in the punch key and then that's kind of the comment out, everything to its right. And we can add title, data, R, it's kind of today's topic. And also we can have author's name, you can put your name there. And also we can have date. And we want those 2 lines comment out. We can select those 2 lines. We can select both lines. And then we use a shortcut to comment out everything you selected. The shortcut is Control-Shift-C. C is comment. So we comment out everything we selected. So we will start with function. So we can start a new section. That comes with another kind of the shortcut. We use Control-Shift-R, and it pops up insert section, and we can put the section name. We call that functions and their arguments. The shortcut key is Control-Shift-R. That will pop up window, ask you for the section title. So we have this section title.
Will you recap the section? How do you get to a section?
Control-Shift-R. So you can create a new section.
Yeah, that would be helpful so they can see where your mouse is going. Good job.
Control-Shift-R. So that will pops up this small windows. You key in your section title, section label. So functions are candidate scripts to fulfill certain tasks. Many of them are predefined in base R. We can see a very simple example. That's the square root, SQRT. That's the square root function. And we can assign that to object or a variable. We call that just A, and we use alt minus. That's the shortcut for the assignment operator. Alt minus. And then followed with square root sqrt. And we can say x equals to 9. And when we run this command, we will say control enter. We will see a new object created in the environment. That's A, and the value is 3. And to check that also, we can run A, and then we see the results 3.
How are we doing in the room? Pretty good? Okay.
Usually, a function gets one or more inputs. We call that arguments. And often functions returns a value like this one. Returns the results of the square root of 9. So that's become 3. And when we execute a function, we say we call a function, or we say we run a function. The arguments can be numbers, and also it can be characters. Last time we kind of print out the famous hello world. We put them in the codes. So when we run it, we see the results. And also some functions doesn't have any arguments. Let's say the one we saw last time, get working directory. When you run the function using control enter, and we'll see our current working directory in desktop Starfy folder. Some functions may have more than one argument. Let's say round. That will round out a decimal number. Let's try x equals to I, and we want to keep the digits two digits, and then we got 3.14. We can also kind of run this function. Just put I in the parentheses. When we run this, we got 3. Because digits, it has a default value, which is 0. Then it will round up to a whole number. Some functions can be kind of complicated, and usually we can use the help function to check how the function works.
Sorry, let me get something. Run x equal pi, digit equal to. What are we trying to do in that command?
We try to round up the pi to a 3-digit decimal, to 2-digit decimal.
Okay. And actually, we are referring to x obtained previously.
Okay, so without the second line, so even you don't have to specify the arguments. You still can just put the value there. It works. Do you mean this line?
X, yeah. Previously, we entered a command previously that says x equals 9. We're referring to the same x, or the x assume another value here.
Okay, so we will get there, right? Okay, so when you use help, to see how this function works. And here is the explanation. And so this is the round function. In the help tab, you will see the round function here. And okay, so round function is defined this way. It has the first argument x, and the second argument is digits. A default value 0, and when we call this function, we can specify pi equals x equals to pi. If we don't specify the which argument we are this value is for, we have to follow the order. You can see the function is defined. I mean, those arguments follow specific orders. So this one, the first argument is x. We didn't specify here because it automatically assigned to the first argument. And the second argument, it has a default value that's 0. That's why we get 3.
Okay.
So you can always go to the help function to see how this function works.
The help function, is it the same as question mark?
Yes, it's same as question mark. Good. And you can, oh, sorry, I don't think I will. Then it will open at the same function. So there's some good practices for calling a function. So, oh, I forgot to mention this one. It already have default value. We call this function kind of options or optional arguments. So this arguments, optional arguments. And when we call a function, usually it's suggested we put the non-optional arguments first. And we suggest to specify the argument instead of kind of put the value directly in this in the parentheses. Especially for some kind of the functions people are not really familiar with, specify each arguments, their names, that will help people understand what you are doing with this function.
Especially if you think you're going to send that to somebody else to run, it will help them read it later, or you read it 5 years later.
Help your future self. And anything else about the function is function, you can nest functions. Let's say we want to round out a square root of, and then put them just the result of this square root will be the input for the round function.
What we're using the other, like square root 47, comma 4.
This comma is separate. You can see here the function is defined this way. This x is the first argument and the comma and followed with the second argument.
But why don't we put, we want the figures to be 4 digits. The square root of 47, we want it to, the result to be returned as 4 digits, right?
Yes.
Why don't we put digit equals 4 like that?
Yes, I can do that. For this round function, it's a very simple function. So if even you did not specify which is which, as it follows the same order as it defined, the function to be round out comes first, and the digits we want to keep follows. So the first, even without specifying using the x equals and digits equals, we still know this one is the digit, the number we want to round out, and then this follows with the digits we want to, how many numbers we want.
I think the digit actually tells, it's more of a number of decimal places than the total number of digits. I mean, the digit tells, I mean, it's a command that will, I mean, how would I put it? It's more of a command to, to put the outcome in 4 decimal places. Not actually, because we have 5 digits there, not 4. You don't know what I'm saying. The digits there in the command is
Digits is, that's
four,
the
right?
digits after the dots. Yeah. Okay. Let's say we have a huge number here. We will still have 4 digits after the dots. It's not, we're not talking about the number left to the dots. So that's all about functions. We're going to talk about something else. Let's talk about vectors next. We can start a new section, use Control Shift R and then vectors. Okay, in R, vectors is a data structure. It's the very basic data structure. It's composed of a serial of values. Those values can be numbers or characters. If all the elements in a vector are of the same data type, let's say if they are all numbers or if they are all characters, we call those atomic vector. If they are of different data type, let's say it's a mix of numbers and characters, and we call that a list or a generic vector. In our workshop, for today's workshop, we will use all the vectors. We're going to use atomic vectors. So we will use vectors refers to atomic vectors. So they are all of the same data type. They are all numbers or all characters. If you read other books about R, they may also use vectors to refer to atomic vectors. So next, we're going to create our first vector. This kind of from our Starfy data household members, and we use alt minus and mod. To create a vector, we're going to use the function C. And so we assign this to the vector household members, and that's how many members in the family. And we have first vector. We'll see it appears here in the environment.
Where's 3, 7, 10, 6?
3, 7, 10, 6. That's the vector.
Where we got it?
The 8.
Yeah, you said vector.
Yeah.
You are talking about household members. And the figures telling us the age of something, particular information about the members of the house. Or what's telling us?
Okay, this is just an example. You can use random numbers, but I picked those 4
Yeah, I
for
understand.
exercise.
Just trying to make sense out of it. To me, it does not make sense yet, but I feel that when we get into it, really appreciate the whole thing we are doing right now. But household members, at least we understand what that means. Like members of the family of their house.
We're gonna come out of the data, we're gonna look at the data, and she just grabbed some numbers so we can do an example now. So, okay.
And also we can check the the value just by typing the name of this vector, and then we run this command, control enter, and we will see the results here.
Use this for data entry,
For data,
entering our data to be like R.
this is just example show how a vector looks like.
Can you tell us what is the implementation of factors in the real life, like when we work with the data? What is the main difference between functions and vectors? Like,
Functions is when you run a function, you have a target to do. That's kind of a script, and the vector is your the value. Vector is, can I say that? Never think of kind of the difference between a function. Function is an action. You do something with your value. You do something. You act on your value. That's the function. Let's say you try to do the calculation. You try to find out the square root of this number, and a vector is a kind of container that's hosts your values.
Okay.
Yes, it's instantaneous here.
Type of this C. Found error.
Oh, C is the lowercase c.
And remember, when you were doing this with your own data, you will know the data a little bit to be pulling it to here. So that's why some of this will just be giving you examples that you don't really understand where they're coming from, but it'll make sense in just a little bit.
That's all.
So
Yeah, I was wondering if I could sit in. I
Okay.
didn't register and then came to look back, but is that okay?
yeah, sure.
Will you sign in on the sheet back there?
So we just saw our first vector. It is kind of all the elements are numbers, and we can also create a vector with characters. And so this one we will call that respondent war type. This is the kind of information we collected with those SARFI number or with those SARFI survey or interview, and those people, those respondents, they talk about their war type. So this is the war made of their houses kind of, and so still we use the assignment operator and then the function C. And this time, as this is a character vector, so all the elements are characters, we need to put them in the quotes. So the first one is just Madao.
These are types of walls or buildings.
Burn break. And the last one is sun break.
And I asked you to zoom in, but if you'll zoom out just one, I think that will help them see the whole line.
And also we can key in the name and run and see the results. we create the vectors, we can just see the content, and also we can kind of look into their attributes. Say we can use if we try to find out how many elements in a vector, we can use the function length. And put the household members function there. And when we run this function, we will see 4. So length will kind of measures the length of your vector, that's the size, and how many elements in this vector. We can also do the same thing to the response, the wall type. So we can see we have 3 elements here. Another function we can use to inspect vectors is str, structure. That will give us a brief summary of our vector. So use str and put the function name, the vector name there, and run that. You will see this is the numeric vector, and it has this is the index of your vector. It has 4 elements, 1 through 4, and this lists all the elements here.
Can you repeat what STR used for to look into data?
STR.
Yeah.
STR is structure, and you can see a brief summary of your vector. So STR for respondent wall type.
Okay.
What type, sorry?
Wall type. I
Oh,
mean,
yeah.
this is the character. This vector, the respondent wall type. That's the name of this vector, and it is a character vector, and it has the index 1 through 3. That's 3 elements, and here follows with the 3 elements. Use LS. Can we use LS? LS to list all the elements you have. So currently you can see we have 3 elements, and you use LS, you can see all the vectors, all the objects you have. Not elements, sorry, I'm saying objects.
See the contents of the object. Use that.
If you want to see the content, you can just put the name of the, and then you can see the
Yeah, I
name,
see.
the content. And also structure give you some content. So when you run the structure and the str function, you see some content.
Yeah, yeah.
And ls is not for those elements, but it's for how many, for the list of objects you have in your current environment. So we use the function C to create vectors. We can also use C to add more elements into an existing vector. So we can see the example, say, respondent wall type, and we assign, we use the C, and then we can start with respondent war type. And then we can add new elements. When we key in to check the content, we will see now we have 4 elements and the 7th comes after the previous one. We can also add element to the beginning. Name and say concrete, and then followed with respondent war type. And this time when we check, we will 5 elements. The first one is concrete, and the original 3 elements, and then followed so for the atomic vector type, basically it has 4 types, 6 types. We already saw 2. One is numeric, and the second one is the character vector, and the other 4 will be logical. That's true or false, and then integer. That's the whole numbers, and another one will be complex. Complex is just a combination of the real number and imaginary number. And the last one is raw. That's kind of another different type. We are not going to cover complex and raw. We will focus on the first 4. Numeric, character, logical, and integer. We know that usually a vector has multiple elements, but sometimes we want to access an individual element or a subset of your vector. So we can use index to do that. In R, we use the square brackets for indexing. So square bracket. So there are several ways to do that. We will cover 2. The first way is to use a single integer number to index. Let's say we still use the one respondent war type, and we want to see the 3rd element. We just use the square bracket and we put 3. And then when we hit enter, we see the 3rd element. So the 3rd one is burn breaks, and we see burn breaks. Also, we can get more than one element using the index. Let's say, still we start with square brackets, and if we have more than one, we need to put them in C. That will make a vector. So we want the 2nd and the 3rd, and also we can have 1 at the end. We don't have to be increasing as for increasing. We can put them in different in whatever order we want. So model, that's the 2nd one, and burn breaks, 3rd one, and concrete. Also create vector, using this index to create a vector. It has more than has kind of more elements than the original vector. Let's say we can have and you will get kind of a larger one. I mean, new element, a new vector with more elements.
Why may we be doing this? What can necessitate us to be doing this? You know, this command we are entering. What can necessitate us to, use this command like to
Okay,
change
so
your
I know it's kind of we're talking about what the function can do or what index can do, but we will see kind of the real examples later. This is kind of how this functions.
works. All right. Actually, I'm asking this question because I'm trying to actually appreciate and make sense out of this. For me, I came
How
here
to
just to
use this
just to
function?
use
Why
it.
do you want to put those things together? And it doesn't really make sense, right? But this is kind of how the index functions or how the And there are two situations we want to mention using the integer to index a vector is the one is negative numbers and another one is the numbers larger than the size of your vector. Let's say, and if we put -2, and we will get a new vector which has only 4 elements. The second element marked out is removed. So minus means remove. So you can use minus to remove elements from your existing vector. Another situation is if you have a larger number, we know currently we have 5 elements in this respondent 4 type vector. If I have a larger number, 7, I will see NA, which means missing data in R. So this is kind of 2 situations when you use the integer index vector. So next we're going to talk about another method to index. So that will use the logical vector to index or subset a vector. So true logical vector is a combination of true or false. So true will select the element with the same index and false will not. So we kind of call that conditional subsetting, and we will see in a minute. So still back to the output numbers. And the one we have this numbers, 4 numbers, and we want to use the logical vector to subset this vector. Let's say, this will be the C that will create a new vector. That's a logical vector. We use only true or false in this vector. So false, and also T, capitalized T is true, and capitalized F is false. Since the second and the third elements are true, And we will see only the second and the third, 7 and 10. Okay, so here is the logical vector we use to index the current, the vector household members. And household members has 4 elements,
Yeah.
and our new logical vector has 4 elements too. And the second and the third, they are true. So which means we will pick second and third from the household members. That's how we index this or subset this household members vector.
Is that another way of canceling out, those elements 3 and 6? Like the way we did it previously, minus the one we did previously.
Yes, it's kind of like the
Similar.
same thing, but we use different method. That one we use integer to index or subset, but this, for now, we are using vector, logical vector to do the subsetting.
So if we start, if we enter the command star household members, are we going to see only 7 and 10 for all? If we use str command, to see or to display the content.
STR, you mean this structure?
Yeah, to see the content of household members, are we going to see all the 4 elements or just?
Yes. Okay, now we use the logical vector to do the indexing, but we did not change the value of these household members. If we assign this, let's say, if we assign this to household members, and then when we check household members, we have only 2. We have only 2 elements here. Right?
Because we changed the data.
Okay. I need to get it back. Okay, I will run this so we can get the 4 elements back. And then I will show you other examples.
Let's say that again, Ching Ching. So if you followed that last little bit that she did, she's going to add all the 4 back in. So make sure you add the 4 back in as well.
So this command, we have that on the very top. So I just run this to get all the 4 elements back. So when we check that, we still have the 4 elements. As I'm going to kind of show you other examples, I still need this 4 elements. So for this logical vector method, ideally we will have the same size. I mean, the logical vector and the original vector, they should have the same size. If not, if they have, they will follow this 2 principles. Okay. So the first one, if the logical vector has less, is kind of shorter than the vector, the original vector you want to index, it will repeat itself. The logical vector will repeat itself. That's the another example. It is. Okay, we know household members has 4 elements, and now we use a logical vector which has only 3 elements to index this, and when we run it, we will get the first and the second elements, and the third will be removed as is false, and the third and the fourth, it will repeat this logical vector, so that will be true. So we will get the first, second, and the fourth. So only the third is out. Another principle is when we have kind of more than 4 elements in the logical vector, so the first 4 that will works its own way, and then this one is false, it won't bring anything back, and this one is true, it will bring the 6th element from household members, but we don't have any elements, the 6th element, so it comes back with an NA, which means missing data. The 6th element of household members is missing, so it is NA. So usually when we use this method, logical vector to index a vector, we won't kind of type in the logical vector. So usually it comes from results of function, or it comes from a logical test. When I say a logical test, I mean, let's say household members, and then I say greater than 5. It will check each element, which one is greater than 5. If it's greater than 5, it returns the true. Otherwise, it will return a false. So here, the first one, 3, returns false. All the other elements, 7, 10, and 6, is true. So that's how we get an logical vector. We can use this logical vector to index. That makes sense. So still, we need to use the square bracket. That's for index. And then we put numbers greater than 5. And it will return all the elements greater than 5. And this logical test can be a combination of several tests. Let's say we want to test less than 4 or greater than 7. Okay. This is the key, let's say shift backslash. The key right under the backspace. And you use shift kind of for the upper one. That's called a pipe. That's called pipe.
Why did we use that?
You use that for all. For the logic all, the logic operator all. So it will return either smaller than 4 or greater than 7. So for our number, we will see 3 and 10. So we get 3 and 10. We can also do an AND logic. And we will use the one kind of on the top of 7. So this time we want the numbers is between 4 and 7. We will see 7 and 6.
That one up there earlier where it was like 376 NA, were you using logical operators there, or was that just like asking you to, were you just trying to spit back elements that you had?
You mean this one?
Yeah, sorry, I'm
This one
misunderstood.
is using the logical operators.
Oh, I meant prior to that,
This one?
where it was just spitting back the like true, the T, true F. That,
Yes, this is the
that was just-
logical. Yes.
okay.
this is logical. And you can see the results of this one. It will show you the logical, the true or
Okay,
false.
got it.
And this is just kind of where it starts.
Yeah, like the word.
What is the and symbols for?
And symbols is for and. That's the logical.
It's 3 p.m. Can we take a 5-minute break?
The logical operator and.
No, they're asking if they can take a break.
It's 3 o'clock, so.
Okay. Okay, let's take a 5 minutes break. Okay, we come back at 3:08.
Do you want us to help you get set up? Okay,
Sure, I mean, yeah, why not?
okay.
I'm here.
We'll try and get as much as we can in there.
I'm not worried about it, I just wanted to sit in.
Yeah, yeah, sure, and I will make sure to send you that,
Yeah, I got it.
So that's-
video, so you can kind of figure out what you're doing. So now we need to extract off.
That's for you.
I think you have to download it first and then extract. Yeah, I already sent it. Should be, maybe, yeah, there you go, yeah. And say, you're on it, man, you're following along, asking good questions, good job. So double click on that, and then we're gonna double click on the bottom one, the blue one, yeah, that's. Yeah. And then we're gonna make sure we add a package over here, so at the top here. Then we're gonna install, then we're gonna look for tidyverse. Oh, I think we did do that, didn't we?
No,
Yeah, we did while you were still talking. Before?
no, we.
Yeah, we did.
Oh, you.
I did while he was, did you close it and then open it? Oh, okay, then it doesn't stay. It doesn't stay on these computers because it wipes it clean. So you have to type in tidyverse. Yeah, V is next and then you can just, there you go. Yeah.
Make sure that it's already checked. Install dependencies every time you make sure this is checked. So, yeah. And then click install as well. Start installing.
It'll take it a minute to go there. And then we just need to get the values in right, so that he has these values here, so that it could be, or you think we not need that now?
You don't really need it.
Okay, so then,
Quickly finish that and. we don't
Then
need
it'll be
those
ready to go.
values.
okay, so we're gonna get you really hooked up then. Tell me what your first name is.
Kevin.
Kevin, okay, I just saw the email and I was like,
Yeah.
I don't know what the,
I just
what
like
your
saw,
name
I like
is.
was like looking, I was like, oh, this looks like relevant to my work, so I should like do this.
And so this is the
So what's
second of
the-
4.
Okay, yeah.
And it's loading the package from tidyverses, and we kind of covered that in the first one, so there are certain things you can add, and so we're gonna use tidyverse and another package, ggplot2, I think, right?
So
And
ggplot2 is for the visualization.
yeah, and so it's just adding it in there, and then once it does do that, looks like it's good to go. Let's go ahead and get the files in here. We have the files in here, and we want to save this now. Into
Hey,
let's see,
no,
we need a
no,
new project. I'm gonna click. Okay. And then we're gonna save this. And when it says save, we're gonna save it as what she has up in the red in the top tab up there. It's like S2 data, and we're gonna put it in the scripts. We wanna make sure we are in this folder. I don't know if we are in that folder before you hit save. Put it in scripts. Yeah. Okay. Okay, you're ready to go to type with us now? Sure. And chat is doing well. They're not asking too much. That's good. How are you doing up here? I know it's a mental kind of grip, right? You got to, we're trying to get everybody on the same page. So that we can really do some work with some data that we'll look at. Yeah, so that's what we'll end up using that survey data, which is really
They have a rough time.
household
literally
members
when
that
they
survey from
have some
even
predator removal
African
or
farmers.
has no effect.
farmers. That's why I was survey from.
Interview those farmers.
And so then we'll see the
Installation.
like the objects they own and stuff like that. So there's like a whole interview process that then we'll integrate that. Okay, cool. We're right.
You did all right?
You was okay. Get started. So we just talked about kind of the two methods to index a vector. We use integer, and also we can use the logical vector to index a vector or subset of vector. So one thing I want to mention, if you use the logical text, if you want to say equals, you cannot just use single equal. You have to use double equal. So we will see equals to 7, and we know we have a 7. That's the second element. So all the others will be false, and this one is true. If you use assign, you use single equal, it will assign this value to household members. So this is not logical test. A logical test, you have to use double equal. So next, we're going to talk about missing data. In the real world, it's not uncommon to see the missing data. And R is designed to analyze data sets. So it includes the concept of missing data. We already see missing data in our previous examples. In R, it used NA, capitalized N, capitalized A, to represent missing data. New section. Still a new section, Control Shift R, and I will type in.
I see that they have environment values here.
Example, that's the rules. We will assign it. Assign it. A and 4. We will assign these values, these 5 values, to the vector rules. It includes missing data and A. Sometimes we want to do some calculation, but when we have missing data, in a vector, we want to do the calculation, it may cause some trouble, it will brings back, the results will always be NA missing data. Okay, so let's say we want to see the mean of the rooms. We get NA. And we want to see max. We got NA. It could not tell because of this NA. So in R, there is an optional argument. It's called NARM. We can use NARM to ignore missing data. We calculate pools. We can add the NARM equals to true, and we get the result 2. So this missing data is ignored. You can do a quick calculation, 2 plus 1 plus 1 plus 4 divided by 4. You get 2. It's not divided by 5. NA is ignored.
You have to put true, like, is true important to getting it to do the NA.RM?
Yes,
Okay.
to ignore the NA.
Okay.
Yeah. The same we can do for two. Are also use functions to handle missing data. The most commonly used function for missing data is if NA. So we can use that to check if there are any missing data. And so we can see all those are false, they are not missing. This one, number 4, it is true, which means this number, this element is missing. This is an NA. So if we want to see those elements, only those elements which is not missing, that's kind of a subsetting from the Torrance rules field, right? So we can use square brackets, that's the subset, that's index. We will use logical vector, which means is NA rooms. If NA rooms, it will get only the value that is NA, right? That's not what we really want. We'll see NA only. And we can add an exclamation mark before is NA, that means not. So this time we are going to bring all the elements which are not NA. When we want to calculate how many NAs we have,
Excuse me. All right. Why use the that mark, like what is called escalation mark?
exclamation mark, which means not, NOT, not. So it's kind of the reverse.
Yeah, so that line reads, if you're really reading it in language, rooms not missing.
So we can also use is NA to count the missing values, how many values is missing, and we can use is NA. For true, it will, when you do the calculation, I mean, true means 1, and false, that's 0. And so when you do the calculation, you calculate all the NAs and you use sum, and you will get the number of missing values.
So if our data set had one more NA, that would pop out.
2. Okay. So she's gonna run up there.
Add a new NA and then redo the calculation. You're gonna get 2.
Thank you.
So this is kind of what we're supposed to cover in the first session. So anyway, last time we kind of talked about the objects, and you can also treat it as the variables in other programming languages. And this time we talk about vectors, and we focus on atomic vectors, which all the elements, are also the same data type. And basically it has 6 types. We will focus on numeric, character, integer, and logical. And to kind of inspect the content and attributes, we can use lens to check the size of an vector, and we can use str structure to check kind of a brief summary of our vector. And we use the square bracket to index or subset a vector. And there are we introduced 2 methods. One is to use integer numbers, and another one is to use logical vectors. And we talk about missing data NA, and we can use an NA.rm when we do the calculation. That will help us ignore the NA missing values. And also we can use the function isNA to check if to find out the missing values. Next, we will talk about another data structure. It is called data frame. Most of the time when we collect the research data or save the research data, we use the format. They will save them as a tabular data. Let's say the CSV file or Excel spreadsheets or Google Sheets. In R, we use the data structure called data frame to for those tabular data. So first, we can see so this is tabular data. It has 3 columns, and the first one is 3 numbers. That's a numeric. You can say it's a numeric vector. And the second column, that's the character vector. And the third column, that's the logical vector. And this is, we can say, the data frame that consists of 3 vectors of the same size. All of them have 3 elements. It's kind of a square or rectangular, we can say that way. Data frames can be created by hand, but usually we use commands to read data sets, or we read spreadsheets into R. before we read our data, we can take a look at what we are going to use. That's the SARFI data and study African farmer-led irrigation. And we have 14 fields or 14 columns that will, the 14 columns in our data set. And you can see that's the key ID and village, interview date. We can make a guess. Let's say key ID, it can be numbers. It also can be characters or combination with combination of numbers and characters. Village, that's the village name, is usually characters or string. And interview dates, that will be the dates. Yeah, that's the data we're going to use. That's the Excel file we downloaded. When you open the CSV, the CSV file, when you open the CSV file, you can see something like that. And the key ID, their numbers, and the village, the characters, and the dates. And also, you may also notice I highlighted in red, in yellow, that's now, which means missing data. And you may also notice something like items owned. It has several, let's say that, several elements separate with semicolon. So usually when we have our research data collected, we want to look at them and see some patterns or see some possible potential issues of our data. And so we can foresee what we are going to do with the data. So we notice the character strings. We notice the character vectors or character type of variables, or we have numeric values. We have all those missing values. It's using now. So now we will start to play with our data set. So back to our we can start a new section. There's a call that. Control Shift R, and then we just call that SARFI data. So first, we need to check, you have this under your data folder, you have this CSV file.
Everybody good?
And click the packages and make sure scroll down to tidyverse. You have tidyverse here. If not, if you don't have tidyverse, you need to install that. To install tidyverse, you need to install. Oh, okay, you can use another way here. You can just click this button, install, and then put tidyverse here. And then make sure install dependencies is also checked, and click install button, and it will start the installation process. May take a couple minutes to get it installed. You will see the red messages, but no worries. It takes a couple minutes, and then when you see your cursor comes back, it should fine. Time we start using a new, we need to install them once. But when we start a new R session, we need to load the package into this session. To load a package into a session, the function we're going to use is library. And then the tidy first. And then you run this function.
So we can just see. We can just see.
Yes, you can check, but the problem with that is that won't display in your script. So if next time you forgot to check and you run your script, it won't work because you didn't load.
Okay. Okay.
So that's why we kind of ask people to write all the commands into their scripts. Yes, you can, after we run this function, it's checked.
Every time I.
And last time we kind of talked about the conflicts. I kind of suggest you don't install too many packages. You install only necessary ones. And when you load your package, it will show you the conflicts. So here, these two lines means the already find conflicts with the existing functions. In dplyr, which is a package under tidyverse, it has a function called filter. And in the meanwhile, in stats, this is kind of in the base R. It has the function using the same name, filter. And now after we load the tidyverse, this the filter in dplyr will masks the one in stats. Let's say if we currently run the function filter, it will use the one from dplyr. So you can see it's from dplyr. If you do want to use the function from stats, you have to put the package name first, followed with 2 colons, and then filter. Put the function name there. This time you are using the filter from stats. We can check the help information. I put the question mark and then the package name and the function name. It brings the filter from stats. If you use filter only, you will see options. And the first one is from dplyr. This is the filter from dplyr. So make sure you are using the correct function. The one, I mean, not correct, the one you really mean to use. Now we're going to read our data into R. The data, we will name it as interviews. And we were going to use the function read underscore CSV. And first we will put the path, I mean the directory of the data, the file, and also the file name. We put the CSV file under data, so it's data and / and the file name is sarfi underscore clean.csv. And when we kind of inspect the data, we know this data using NULL now for missing data. In R, we use NA. So we will add this optional argument. We will put NA equals to now, and then when it will read our data in. we see we have 7 character variables, we have 6 double, with this DBL means double. We can think, we can kind of think they double and numeric are the same. And this is time and date, date and time. We have 1 date and time variable.
So you give a pathway in the data,
Which,
it's a data slash Safi clean and CSV, right?
yes,
And like it was in my same folder, so I just wrote like Safi clean CSV. I didn't have to put the file. Show you. The part. Because it's in the same folder.
because you have this, yes, in the same folder, it's not under data.
Okay, so if it's in the same folder, I don't have.
You don't have to.
Sorry, what does the double mean again? Is that numerical and categorical?
Yeah, it's numeric, double means numeric. The same
Got it.
thing. It's kind of like storage. Mode or something.
Wait, can I see the end of the interviews line?
Oh,
I'm sorry, if you'll just scroll over, yeah, thank you, that's what I needed. Okay, you can go on.
So when we use the, we can kind of look at this read CSV function together. Okay, so you can see it starts with read LIM, that's read delimiter. And it's from the read R, which is a package in the tidyverse. And so we can see from here, read CSV, read TSV, those are all kind of different versions of the function read delimiter. And let's go down to this one, read CSV. So the first argument is the file. We specify by pointing the path and the file name. And then all the other functions, all the other arguments are optional. So let's say the first one is the column name is true, which means the first column name, okay, the first row of this CSV file, that's the header. How did I know that? Okay. I'll give you the explanation. So true means the first row of the input will be used as the column names. And also we want to see something like NA. We specified NA, right? We use now. Oh, yeah, here. By default, it's either nothing or NA. But for our case, we use the NULL to replace this too. Sometimes it may be difficult to read or understand the document. And you can always scroll down to the bottom. It always have some examples to show you how function is used. So kind of the same as when we learn the vector, we will also use we use kind of the functions to inspect vectors. This time we're going to use functions to inspect data frame. So the first we want to see the size of a data frame. Different from vector. Vector is kind of one dimension. data frame is two-dimensional. So we have a number of rows and number of columns. We use the function DIM, and we check the interviews and did I spell it wrong?
Oh.
Yes.
That's what some people were telling me, it's not working, I'm like, goodness, she said, oh, she spelled it, and I was like, oh no.
Great. So if you spell it wrong like me, so you can just correct it by rerun this row, and then it should work. Mention interviews, and we see we have 131 rows and 14 columns. If we specifically want to know the rows, we can just use our row. And the column the same. And column. If we want to see the content, we can use the function view. It opens a new tab besides our editor. So it will, you can just use the left, right, and up and down scroll to see the whole data set.
Can we see the script so we can know how to get there?
Okay, so view, we use the function view. And sometimes we may not want to see the whole data set. We can use head to see the top rows. And you can specify, you can see the first row. So this will be the first row. There's only one row and 14 columns. And the number of rows is an optional argument. If you don't specify, it will display 6 rows. The same if you want to say you want to see the most bottom rows, you can use tail. That will display the most the top 6, the bottom 6 rows. And you can also specify.
So maybe we should check now. How's everybody in the room? Good. And I hope chat is good. If not, let us know. All right. Yeah. You're having problems. I'm coming.
And you can check the column name, use the function names. So here it lists all the column names. And if you want to see kind of summary, we use str to check a vector. It also can be used for data frame.
Sorry, name stands for columns or rows?
Names will brings all the column names. So you will see the key ID, that village, that's the name of each column. And str will brings you a kind of brief summary, and you will see the PID and its numeric, and it has 1 to 135. That's the index, and also you will see some of the elements, the first several elements.
Oh, I'm gonna.
And also, let's say at the top of the results, you will see the spec which means tibble, and that's the data frame. We know data frame, what tibble is. Tibble is kind of like a lazy data frame. We can say a tibble does less than a regular data frame. What do I mean does less? Let's say when you use the hat, when you use hat, it will display, depends on the, do it again.
Jing Jing, I'm sorry, can you scroll up just a little bit in the script? I think we have a issue here. Just scroll up for a second for me. In the script? On your
Okay,
screen, if
scroll.
you'll just scroll over the script for a second, then I'll look at what I need to know. To the top, like 109, yeah, like there we go. Okay, thanks.
When we change the kind of the hat, it displays, depends on the width of my screen. It doesn't really display all the columns. Let's say if I have a smaller screen, I run the hat, and then it display only five columns. If we have a larger screen, it displays more. If it is, this is how tibble functions. I mean, tibble does less. If it is regular data frame, it will display everything. I can show you what I mean, but you don't have to follow along. You can always use the function as data frame to convert a tibble back to the regular data frame. And when I convert it back to a data frame and I run the hat function, you can see it displays all the columns. So this kind of a tibble and data. Tibble is a data frame, but not all the data frames are tibbles. And tibble, sometimes it kind of works pretty well with all those functions in tidyverse, but it may not work well with all the other functions or all the other packages. So sometimes if tibble doesn't work with the function you are going to use, you can always convert tibble to a regular data frame using this function as data frame.
Can you repeat it, please? Like, as data framework, and how we can use it for work?
And you can convert a tibble back to a regular data frame. So that's kind of the difference between tibble and a data frame. So we can also use summary to check the data frame. So it will do the statistical calculation, statistical summary. Let's say, if it is numerical data, it will calculate the minimum, maximum, mean, median, and the first and the third quartile. And if it is the character, it will show you the length, the graph, all of this. So those are kind of functions we use to inspect So quite similar, we are going to talk about the index and subset of data frame.
Before you move on, Qing, since we're right at the end, we only have like 15 minutes left. I think there's a few of us that are a little lost. And so if you will kind of, maybe in chat, they were asking about what happened on line 109. I don't even know what happened on line.
Okay,
Okay.
to run this function, we can. That's, well, opens the data frame, that opens the data in a new tab. You can view the whole thing.
Yeah, I think we had a hard time opening the data, or quite a few of us, when we were doing the filter, the stats line, and then we had to do a filter line, then it changes on yours, and if they didn't see that line on yours, then they didn't ever see it.
Okay,
Because it changes from this filter to the stats line, remember?
okay, yeah, I
Yeah.
think that's because I kind of misspelled interview. So,
I mean, pulling the library title universe, then you say stats equals colon something.
oh,
And so I think people miss that line, and if they were just looking at the screen, it changes to this.
okay, got it.
So I think that will help people understand what happened.
When you install, when you load a library, you will see some conflicts. Yeah. When we load the library ID first, and we see some conflicts. And here, the filter, if you use the filter, which means the filter from dplyr, the filter function from the package dplyr. But if you, there is another function called filter, but it's in the package stats. If you specifically want to use this function, you have to use it this way. You have to have the package name and followed with colon and then filter. So I don't have any example for that, so but I can quickly bring the help document for this one. So you see filter, it is the filter from stats.
And then the next line here would be the question mark with filter itself.
Yeah. And this one, it will bring kind of two help documents. The first one is for dplyr, and the second one is from stats. You can, if you specifically want to check from dplyr, you can click that one, and then you see filter from dplyr.
Okay, I think that helped in chat at least.
Okay. So we can quickly talk about the index and subsetting, as we just talked about the index and subsetting for vector.
Okay, there's a follow-up question in before we move on. Just to confirm, default to dplyr, but I can change it to stats, and the question mark is where she is showing that what they mean. So the question mark is just the help.
Yes, it's just for the we can. As I don't really have any examples to use
Right.
filter. If you do want to use that, you have to put your
Whatever it is there that
Yes.
you want to, yeah. Does that help? Yes, we got it. Thank you, Jing.
So we will quickly talk about index and subsetting of data frame, and we use the square brackets for subsetting or indexing the vector. We can also use square brackets for data frame, and beyond that, there's another two symbols we can use. One is double square brackets, and another is $sign. We will cover this three. So first, let's say we know that data frame is two-dimensional. So interview, if we want to get the first, so we still need two numbers to index data frame. We want to see the first element of the first row of the first column or first column of the first row, and we get this one. This is the key number for the first row. And we also notice this comes with, it's also a table. It's a 1-by-1 table. Even it has only one element, it is still a table. And also we can use that for kind of other columns, let's say interviews. And we will see rooms. Yeah, that will be the respondent ward type. That's the first element. And also we can have multiple elements. Let's say we try to get the first 3 rows, but we want only the column 6. So we see the raw materials only from the first 3 observations. If we want the whole row, we can just use the row. We can just use the row number and followed with the comma. And we will see the first row. All the elements. First row. The same if we want to see the one column, we can start with comma and then so that will bring the whole column. It display only the first 10 elements. For columns, we can, it's not necessary to use the comma. It still brings the same result without the comma.
Okay, Gigi, we're about 5 minutes out and the room is booked at 4.
Okay.
Can I ask a quick question?
Mhm.
I guess you could do the same thing in Excel, but can you put a numerical value to these categorical columns? So like I want to know how many total park bricks there are, how many total whatever this is. You get what I mean? Putting like
You
a
want
value
it's,
next to.
We did that earlier.
Okay. I thought I might have
just-
gotten
yeah.
it earlier.
A summary in an index using a summary or a summation to know how many of each kind there are.
Categorical thing.
Yeah.
Because I see the summary stats is useful for numerical stuff. Yeah.
And do you mean this?
Oh, is that okay?
Is that, do you mean the
Oh, I didn't mean
kind of we have this is the type of each column?
No, I get that. That's the labeling. I just meant like, putting like numerical totals next to your categorical labels.
Like how many of each observation?
Yeah, like
How many mud brick or whatever, mud
Yeah.
dog, brick bricks?
Oh,
Maybe each
yeah,
one.
you want to
Sorry,
do that?
that's, I don't know if that's,
Talk about next.
okay, got it.
You kind of give a table in Excel, right?
Yeah, because that's a, you can do the same thing in Excel, but I was like, can we just do it here too?
Yes, we can, but we will talk about that next time.
Got it, thank you.
So if we would like to do the survey, we might show people where that survey is on the guide. And I dropped it in chat, and then we'll need to wrap up so that the next people.
Okay, so we have to stop here, and I think we can. Search guide.
Well, you might show them how to get to it since you want them to go to it.
Okay, so you can go to the library
We can't
website.
see what you're doing because you're on the other screen.
I'm not aware of that. And so you can go to the library website and click the research guide. And then you can search R. And we have R for beginners. And here is our evaluation form. And here are all the coursework. And then you can go to
It's the second link at the top. Why don't you leave that up instead of those? We don't need to see those. They'll see that. Yeah, and then everybody in chat, it is on the, I sent it to everybody as the link. So if you'll fill that out, that'd be really great. If anybody has any questions, yep, that's right. That's right. You're in the right spot.
Please send us questions and yeah, we will try to answer that for next session.
I was so interested in that issue. I could not figure out why that wasn't working. I'm gonna talk it over with Jean and see if we can figure that out.
Okay.
Thank you, everybody.
So you can save your file. I mean,